Outcome 3B, Lesson 1, Surface Area. The surface area of a right rectangular prism is twice the area of the top face, so that gets rid of this area and this area. Twice the area of the front face, so that's the front and the back of this box, so that's this piece and this piece behind, as well as twice the area of the two sides. So let's look at how this works for this one. So I'm calculating the surface area. I have a top and a bottom. So the surface area of those top and bottom is the area of this rectangle here. To calculate the area of a rectangle, we do length times width, and so it's going to be 80 times 35. And because there's a top and a bottom, there's two of them. So that's the 2 times the area of the top face. Then we're going to have a front and back. So the front is this rectangle here. So because there's a front and back, 2 times the area of that rectangle is 45 times 80. And then we have a left and a right. The left and right are the 2 ends on this rectangle. So here's one. That end, so because there's 2 of them, it's 2 times 35 times 45. And then we need to add up all those areas. So first of all, multiplying 2 times 80 times 35 gives me 5,600. The next one gives me 7,200. And the last piece is 3,150. When I add all of those up, I end up with 15,950. And my units are centimeters, but because I'm working with area, they're actually square centimeters. The surface area of the right cylinder. So we're going to look at all kinds of different shapes and learn how to calculate the surface area. Surface area is 2 times pi times the radius squared, and then we're going to add to that 2 pi r times h. So in our example, the surface area is equal to 2 times pi, well pi is 3.14, times the radius. The radius of a circle is the distance from the center to the outside. So in this case it's 2, all squared, plus 2 times, and I'm in this part of my equation now, pi is 3.14. The radius again is 2, and the height is 5. You need to be careful when you're multiplying this out because we need to follow the order of operations. So you need to take care of this exponent first. So you're going to do 2 squared, then multiply it by 3.14 and multiply it by 2. When you do that, that first part works out to be 25.12 plus, multiplying the second part out, 62.8. Adding them together should give you 87.92 centimeters squared. A sphere, think of it as a basketball, and this just gives you the definition of it. The surface area of the sphere is calculated as being 4 times pi times the radius squared. The diameter of a baseball is approximately 3 inches. So from here to here is 3 inches. This means that our radius is 1.5 inches. Determine the surface area of a baseball to the nearest square inch. So the surface area of a baseball is equal to 4 pi r squared. So 4 times 3.14 times the radius, which is 1.5 squared. Again, in your calculation, remember that you have to do that 1.5 squared first. So if I square 1.5, I end up with 2.25. Now I can multiply those out, and I get 28.26, and my units are inches squared. You'll have a list of formulas for this assessment, and you just need to know which one is for which and how to apply them. Now we have a right circular cone, is a three-dimensional object that has a circular base and a curved surface. The height of the cone is the perpendicular distance from the apex to the base. So the apex is this pointy part. So from here, straight down in the middle of the cone is the height. If we follow along one of the sides or one of the surfaces of the cone, that is called the slant height. The surface area of a right cone is the lateral area plus the base area. So the base area is just this circle, and this circle has an area of pi r squared. The area of the outside of the cone we can find by multiplying pi times the radius times the slant height. So a right cone, so here's my picture, has a radius of 2 feet and a height, so the height goes right down the middle, of 7 feet. Calculate the surface area of this cone. So surface area formula is pi r s, so that's the area of the cone part, plus the area of the base, which is pi r squared. So you can see in our formula we don't want the height, but the slant height. That slant height is on this surface. So if I draw just that triangle, I have the height is 7, the radius is 2, and I need to calculate that slant height. To calculate the slant height, I can use Pythagorean theorem. So s squared equals 7 squared plus 2 squared. So s squared is 49 plus 4. S squared is then 53. To get s by itself, we're going to take the square root of both sides, and on your calculator, when you do that, you end up with an approximate answer of 7.2. And these, of course, are feet. So plugging into our formula, pi is 3.14. Our radius is 2. S is our slant height, which we just calculated to be 7.2. Plus, now I'm in the second half of the formula, pi again is 3.14. The radius is 2, and this time don't forget to square it up. Watch your order of operations as you multiply this out. The first part you should get 45.2, and for the second part you should end up with 12.56. Please make sure you check on your calculator that you know how to get those answers. Adding them together, we have 57.8, and because we want it to the nearest square foot, this means that it's about 58 square feet. A right pyramid is a three-dimensional object that has a triangular faces and a base that is a polygon. The shape of the base determines the name of the pyramid, and the triangular faces meet at a point called the apex. The height of the pyramid is the perpendicular distance from the apex to the center. So our base is this bottom piece. These are the triangular faces, and the height again is from the point right down to the bottom base. When the base of the right pyramid is a regular polygon, the triangular faces are congruent. And the slant height of the right pyramid is the height of the triangular face. So if we're looking at this side and we're trying to calculate the area, this slant height would be the height of that triangle. The surface area of a right pyramid is the sum of the areas of the triangular faces and the base. So if we were doing this right pyramid that's here, I would need to calculate the area of the three faces as well as the base and add those all together. So let's start with a square pyramid. If we're doing this, we have the surface area. We need to find the area of the base plus the area of the faces. Well, the area of our base is this square down here. If it's square, we're going to do length times width, which in this case is 6 times 6 because it's a square. And then we have to add in the area of the bases. Because our base is a square, all 4 faces, or all 4 triangles, are going to be exactly the same size. So we're going to do 4 times the area of one of those. So we're looking at this side here. The area of a triangle is 1/2 the base of that triangle, which in this case is 6, times its height, which we are told is 11. Multiplying these two first, 6 times 6 is 36. Then we want to multiply out the area of our faces. The faces work out to 132. Adding those two together, we end up with 168 inches squared. In this next one, because we don't have a square base, not all the faces are the same. But our process ends up being similar. So the surface area here is equal to the base plus, now the front and back sides of these are the same, so I have 2 faces and then the other 2 faces. So our surface area is equal to the base, which is 5.4 times 2.8. Plus, I have 2 faces that have a triangular area. So area is 1/2 the base. Let's do the front first. The front is 5.4 times the height, which is 8.7. Plus, I need to add to that the area of these 2 sides. Those 2 sides, the area again is a triangle, so it's 1/2 the base. The base on that side is 2.8 times the height, which is 9. So the area of the base, when I multiply it out, becomes 15.12. The first 2 bases work out to be 46.98 in total, and the last 2 faces become 25.2. Adding those 3 up gives me 87.3 meters squared. It's now time for your first practice.